Yeah, how you guys doing? Did you get some beer in the break? All right, that's good. Then at the very least, the pressure is off a little bit. If you're bored, you can just have your beer and think of what summer is going to be like here in the Netherlands in the next few months and so on and so on. I don't know. Hey, so thank you guys for the invitation. It's always nice to speak to Snowplow. We're working with Snowplow a lot at Tasman. I'll tell you a bit more about how we do that and what we actually do. But first of all, the kind of thing I want to talk about tonight is, and I thought about this a little bit over the last few weeks, rather than go very deep in any kind of interpretation or technological detail, I want to talk a bit more about the kind of pitfalls that we see in our company when it comes to business and data science. So I think, Stephen, this probably comes a little bit into your direction as well, where one of the most funny and the most unfunny parts of our jobs as data scientists is interact with the people who pay for what we do. So that's what this is going to be about. This is, of course, there's no guarantee whatsoever that this advice is useful or even relevant for you, but please feel free to stop me at any point and kind of discuss about the finer points of the things that we do. So, hold on. Okay. There we go. So we're called Tasman Analytics. We were founded about 2 years ago. We're three co-founders. We're working with a couple of brands out there in the Western European startup sector. We're a services company. So what we do is we come in to young, early stage, direct-to-consumer, heavy growth companies, most often venture-backed, to help them set up in a couple of months a sort of data infrastructure that they can actually scale, that they can hire a team for, et cetera, et cetera, et cetera. Now, just to get a feeling of who's in the room here exactly, who would call themselves a data analyst? Raise your hand. All right. Who would call themselves a data engineer? All right. And who would call themselves a data scientist? That's a thing. All right. And there's a few data scientists over there. I have no idea what the exact difference is between a data analyst and data scientist. So hopefully you can illuminate me later tonight. Who here is more in a management position? All right. Who here is in a management position without having done data analysis, data science themselves? Awesome, great. All right, I'm going to direct a few of these things in your direction and a few of the other things in the other direction. That's great. So it's actually our job as Tasman to work with you guys. As in we come into companies that don't have a data science team. We come in, we say, hey, we think you need a data science team because of X, Y, Z, that we'll go in a little bit. And then we help them build a platform, build an infrastructure, help them hire their own data science team, put all the gears in motion, put all the processes in place to make sure that they can use data to scale their company 2x, 3x, 4x, et cetera, et cetera, et cetera. It's a very diverse set of companies. Some of them are gaming companies, others are more lifestyle companies. Business of Fashion is a trade magazine. Canon, it's actually Canon Europe, so here in Amsterdam, which is of course not a gaming company, but a photography company. A very recent win for us was The Collective, which is a big kind of co-living company in London. But all of them are heavy growth and heavily incentivized to kind of use data to grow. Now, we have 3 principles that I think we'd all agree with, which is that all companies should actually, at the very minimum, own and control their own data for all the reasons that Kara mentioned in the first talk. I think the ecosystem is going much more towards data as a liability as well, which means that rather than kind of pushing it away to third parties where you're actually still responsible for it, right? If you're sending through cookie data from your website to a lot of third-party companies that process that data, it's not that you're no longer liable for it. It's just that you don't control it anymore and you don't have any idea what's happening to it. So we think that companies are going to be more and more inclined to incentivize to own and control their own data. Also, you as a company, you really need this kind of single source of truth. If you still have 5 or 6 different sources of data that all tell a slightly different story, which probably is a scenario that all of you are very familiar with, that is something that you need to get rid of as quickly as possible. And then I think obviously having a self-serve data reporting infrastructure, that's probably the most opinionated piece of kind of principle here, because data reporting has, of course, for a long time been done. It's easy to do some data reporting, right? As in, you just kind of take some SQL export that you have, you punch it in Tableau or even in Google Sheets or something like that, and graphs pop out. But having business users in your company that are able to build their dashboards themselves to us is kind of one of the key components to help your company grow. If you're not able to do that, I've only seen companies. I think I don't know any company where the data team is not set up for self-serve, where the data team is doing anything else but 80% of the time just building dashboards for the rest of the company, because that then becomes the bottleneck for every decision you make. You can't have a data-driven culture if your business users cannot analyze data at speed of thought by building their own dashboards, if that makes sense. Right. So that's at the minimum. There's obviously a lot more that companies should do. We try and help them with that. We come in a matter of 6 to 9 months or so. We set up infrastructure where people own their own data. We set up one single pipeline, in most cases it's Snowplow, to make sure that they have one single source of truth, optimized for accuracy and reliability. And we set up tools like Looker and so on to make sure that self-serve data collection and data reporting is there. Now, along the way, there's quite a few pitfalls that we actually keep falling into. And I thought it would be instructive to, rather than talk about all the kind of successes that you have in data science, actually talk about 5 big problems that we saw over the last year and a half. A lot of these problems I will describe them more in the abstract, but I might be tempted to give 1 or 2 concrete examples of concrete companies that fell into that. We'll see how far along in my glass of beer I get when we get there. So I think the pitfall number 1 is something that both Kara and Steven already alluded to, which is that at the end of the day, as a data scientist, you're solving a business question. It's easier said than done, because in most cases, certainly when the company gets a little bit bigger, when the data science teams get bigger, there's a big temptation to either because you've already solved 1 or 2 business questions in the past, or because it's much more interesting to kind of dive deep into the machine learning part of the job, to start answering the question before the question itself has actually been posed accurately. So getting that kind of order right, where first you nail down the business question, only then do you start solutionizing. And it means that actually in a lot of the cases that we see, particularly in small companies that don't have any data infrastructure whatsoever, sometimes just doing a simple output of the data pipeline into an Excel report so that the business owner can just play around with it, that might be a perfectly acceptable solution to the question that they have. In other cases, if it's a little bit more insightful, if it's a bit more around the kind of why rather than just the what or the how, a very simple regression for the data scientists and data analysts amongst us often has the same sort of value, certainly for smaller company, as any neural network can bring you. I'm not talking about the kind of deeper image recognition problems and those kind of things, but when you just are interested in, well, what is actually driving people to convert, or what is the kind of aha moment of when people realize that the app is for them, most of those questions can be answered with very simple statistical methods. And if the very simple statistical methods are not sufficient to solve those problems, in my experience, a much more sophisticated statistical model is not going to solve it either. Quite reverse, it's going to make the results a lot less interpretable. And that interpretability, that circles back again to why it's important to define the business question first. There's an 80-20 rule here as well, as in sometimes you can get 80% of the value and only 20% of the work, so to speak. So we tend to optimize for, at the very least, iterations, where if we have a business question like a driver analysis, we start with the very simple things like, have you thought about plotting the data? Have you thought about just exploring the simple KPI visualizations? And then we go to the more simple statistical inferential questions where you talk about regressions, where you talk about simple driver analysis. And only when that's exhausted, we tend to go to the kind of more sophisticated things. I put it as a first pitfall because it's an easy mistake to make as a data scientist or data analyst. You would be surprised how many senior leaders in even very big companies make the same mistake, as in trying to solutionize not just data science or data insight, but trying to already have a perfect infrastructure in place before they even know what sort of questions they actually want to answer with the data science or with the data platform. There's one exception to all of this, and the exception is actually what used to be very important in the past, which was predefining a lot of the units of analytics that you were looking at. And by unit of analytics, I mean things like a session when you talk about web analytics. things like a mobile session when you're talking about mobile app analytics. It used to be the case that you had to already define those things before you even started your analytics things, because they kind of hooked into such a fundamental level of your event tracking on app or on website that you had to define that a session is when there was a new session starts when there's 30 minutes of no activity, etc., etc., etc. But with Snowplow, because everything is event analytics based, you can actually be super flexible with all of those definitions. You can say 2 years down the line, I'm now going to change my session definitions to 60-minute cutoff rather than a 30-minute cutoff, and you can do it. Not a problem in the world. So that's actually where you can start doing some of the science part before nailing down the exact business question yet. That's the only exception I know. Pitfall number 2. This is there a strategy actually involved in the kind of data science work that you're doing? So it's probably in our experience it's a problem that arises with almost every client that we have. The reason for that is that data science is difficult. It's easy to kind of go read a few blog posts to kind of as a manager subscribe to something like Data Elixir or to go to a few AI conferences and think that you know what data science is. In reality, it's actually very difficult to come up with a good data strategy. And by strategy, I don't mean we're going to collect some data on the website and then we're going to put it into Looker. No, strategy is really, okay, what sort of business decisions do we want to be informed by our data? It's a very big difference whether, for example, as a company, you are going to be getting your competitive advantage from your data insights from your users, or whether as a company you're going to try and optimize just the behavior on your website with data analytics. One of the discussions we've had with one of our clients was, okay, you've kind of come up with this revolutionary new idea in this market space, but do you want to be a tech-led company in this market space, or do you want to be one of the classic companies in this market space that just has tech as an optimization approach? So, for example, the difference is, are you going to be Marriott having a tech layer on top of their website so they can combine hotel information from Starwood and Marriott hotels and so on and so on, or are you going to be Airbnb? Because at the end of the day, they still sell rooms per night to customers. Airbnb is a tech-led company where everything revolves around the central platform, where everything revolves around this technological solution. Marriott is a classic company that just uses tech as an afterthought to solve some of their already existing problems. Having that in place first as a business strategy is crucial, because if it's not there, it means that you cannot start even beginning to answer your data questions, right? It's something that most startups actually struggle with quite a bit. There's actually no shame in just copying what other players in your field are doing. As in there's this whole kind of Paul Graham and Andreessen Horowitz strategy where they say, look, copying what other startups are doing is actually sometimes the best way to just get ahead and just kind of make sure that you don't waste 12 months coming up with a creative solution that turns out to be more or less the same as what other companies are doing in the first place. But still, you need something, you need a vision there. Now, even if you have a vision, that might not be enough, as in you might not have any buy-in from your stakeholders in that vision there. So what do you do then? And that's the scenario we've also struggled with, where we were working with a very senior stakeholder in one of the companies we work with that had a big, completely well-developed strategy where all the little kind of roadmap items were already laid out, like in April 2019 we do this, in May we do that, in June we do that and that and that. And then all of a sudden, a few months later, you get a message, yes, but we have to kind of divide the budget by 5 because we didn't get any buy-in from the board for all of these things. Knowing whom you're selling to, knowing who the final decision maker, not just for the strategy, but also for the budget is, who's paying for the analysis at the end of the day, is something that's not only relevant, I think, for services companies like ours, because we're never fully integrated into the companies that we work for. We're always an outsider, so we always have to kind of be careful who we sell the project to. I think it's also quite important for analytics teams that are embedded in bigger organizations, as in it's important who makes the final decision at the end of the day, and are they aligned with the strategy that your stakeholders that you talk to on a day-to-day basis are presenting. It's also the kind of thing where most of the rejections that we see from older stakeholders that don't necessarily have developed the same strategy are quite soft rejections. It's never like, we don't see the value of data whatsoever. because even some of these people don't. It's a very bad thing to say, of course, that you don't see the value of data at all. But it's more about prioritization. It's more about they might not see the same burning need as your initial stakeholder sees. Having that conversation very early, making sure that if there's a problem that you get aware of that problem very, very, very quickly in the process is super important. Sometimes it's also not just about that they don't necessarily see the burning need, but also that they don't necessarily see the return on investment. So the return on investment, for me, that is not just a monetary return on investment, it's also about, well, where do you want to position the company a year from now, 2 years from now, 3 years from now, all of those different things. But it also means that as a data scientist or as a data project leader or as a data manager, or however you want to call yourself, you need to be very clear on what the impact on the business is of any piece of work that you're doing. In kind of our experience over the last 2 years, the most successful projects that we ran, we actually had a very clear return on investment estimate. We could say we can boost the effectiveness of your marketing campaigns by 20% in 6 months' time when we do this and this and this. And often that was even underestimated because you talk about quite big changes in the marketing efficiency levers that a company can pull. But it's important to think about that. It's important to have like a success scenario, a failure scenario. It's important to think through all of the different things that a board level decision in a company like that would think through. There's a reverse problem as well, as in one problem is not having any buy-in from stakeholders. The other problem is having too much buy-in from stakeholders and ending up with something like this rather than the unicorn that they were striving for. So that's also something that you should be very careful for, because the whole kind of we're promised unicorns, but we got a zebra with a party hat on or something like that approach is much easier to get into than you think, because I think we're all very enthusiastic about data science and the abilities and opportunities of data science. Sometimes that goes very well, right? And you kind of deliver more than you hope for, and you kind of see much more impact than you think you would have seen. Often, you also get into typical IT landscape problem area where projects take 2x what you thought they would take. You see a lot of kind of unforeseen complications rising up, et cetera, et cetera, et cetera. And at the end of the day, you end up with a prototype at the stage of the project when you actually promised the full result already. And that's something that is almost more dangerous than not having enough buy-in from stakeholders, because if you got the buy-in, you can basically only screw up once, and then you have to kind of be very careful with how you progress from there. That's probably actually the biggest danger that I see with most of these companies, because when we're able to kind of start a project in a company, it's often because the leadership has really bought into the whole idea of data science as a competitive advantage. But it's very easy for them, because they're not necessarily technical, it's very easy to kind of massively overestimate the magic aspect of what data science can bring them and how long it takes. And like your example, Stephen, that they now spend quite a bit of money on getting the pipeline up and running, but then they want the graphs and they say, well, that's not the same thing. Hold on, wait a minute. So getting that as a kind of very clear expectation management there is going to be quite important as well. Pitfall number 5 is bad data. I didn't find a Brexit-related thing here, but I have like a whole pile of dominoes where just one little piece of bad data can turn this into this. As in, it's a really critical kind of base assumption, and I think it's much more of a problem than people think it is. I think a lot of the bad data examples, and again in our experience, are things that just slip under the radar. As in, knowing bad data is knowing that there is bad data assumes that you've already kind of found out that you were sending the wrong events. But finding out that you're sending the wrong events assumes good QA. It assumes that you actually know what the right events should have been, et cetera, et cetera, et cetera. So I always assume that whatever setup we have for a client company, there will be wrong events in there. And then I see it as our job to make sure that there's enough redundancy so we can quickly see whether the events are consistent. I see it also as my job that we have methods in place to continuously QA and iterate and test and unit test, integration test, et cetera, et cetera, et cetera, doing all of the different things that are necessary to uncover bad rows. It's not just about having bad events that collapse your pyramid of dominoes. It's also about locking data into places that are inaccessible to the rest of the company. So for example, if you haven't really thought through the structure of the events that you're sending, And all of the events are, for example, sent in really weird enumerated lists or something like that, which it might make a lot of sense if you're the engineer implementing the SDK integration in the app, but might not be very useful if you're the analyst actually having to use the data and having to join to a dictionary table every time that you see the results, right? Having that. It's also, for example, things like rather than using Snowplow, using things like production logs for analytics. It's not ideal. We know that production logs are optimized for traceability and root cause analysis for engineers. They're not optimized for analytics in any way whatsoever. Quite reverse, as in with logs, there's no inbuilt deduplication. There's no proper kind of, okay, what happens when I can't write the log line, etc., etc., etc. There's another factor here, which is that if as a data team you don't control the full vertical stack of your data integration, if for example as a data team you just consume what the engineers are sending to your data pipeline, that almost always causes big problems sometime down the line, because if you don't know the exact assumptions and the exact definitions under which the events are being sent to the data pipeline, then actually analysis becomes very difficult. That's also when bad data can crop up without you even knowing it. If, for example, you have no idea exactly how the screen view event is generated, you always assume that it's generated from the moment that the screen loads, but the engineers assume that it's only generated when the screen has fully loaded and the user is interacting with it. That makes a big change in how you deal with your customer flow through the app, for example. So making sure that you at least know and hopefully control all of the event definition stack. Just a question, as in does this more or less cover what the kind of pitfalls are that we see, or do you guys think of any other pitfalls that you've encountered recently that are not on this list? Great, that's awesome. You're a really good team. It's amazing. So just a few things on how we get around this, and then I'll make way. We always put in a ton of strategy before we even start to work. So we typically work in sprints with our clients. Sprints help us de-risk the kind of promising unicorns after 6 months, but all you get was a horse with a stupid cone on his nose problem. But it also makes it very understandable for your business owners what the kind of value of the work is going to be after every sprint. Sprints are kind of agreed between both parties what you're going to do in a sprint. With regular cadence, it also forces us to actually follow agile methodology, which is, to me, the most easily communicatable kind of list of this is what you're going to get in 2 weeks' time approach. It also forces us to have a bit of a long-term roadmap where all of your kind of backlog deliverables are going to be defined from. The first 3 sprints are almost always very heavy strategy-based, where we do stakeholder interviews with almost everyone in the client that we can get our hands on, and then we start executing only from sprint 2, sprint 3 onwards. That actually pays off quite a bit. And then in all of the other work that we're doing, we have very clear kind of specification and requirements planning in all of our sprints as well. So if we, for example, start work with BI setup, we first do 2 or 3 weeks of requirements gathering before we even start to work there. So that's the kind of iterative approach that we do. Then in terms of solving some of these other problems, centralizing your data pipeline, getting one single source of truth. I'll skip over this a little bit, but this is quite a representative setup for most of our clients. It should be quite familiar. Certainly on the left-hand side, what clients typically have is data collection in there. So you have, of course, website and mobile app data, and then you have a bunch of third-party services that are generating data. Being able to put it all in the same pipeline seems trivial for those of you that have used Snowplow or Segment or any like platform over the last few years, but actually it's not trivial whatsoever. I think a lot of companies are still plugging that third-party data into the data warehouse, into the database via a super different direction than putting it all through the data pipeline. Being able to validate your events in a central way in that data pipeline before it starts hitting any business-critical stuff. That's one of the things that Snowplow allows you to do, and only since very recently are companies like Segment and Amplitude playing catch-up with that approach. And then having the same database, the same single source of truth, feeding not only into your reporting tools, but also into any analysis that you're doing on the back of that, or into any kind of action streams that you have, whether it's sending dynamic discounts to some of your users, whether it's feeding segments back into your marketing tools, where you're sending particular email campaigns to users that fall in a particular group. it all needs to operate on the same set of data. And I realized that some of these tools that are mentioned there in the red are not making that easy, as in not all of these tools have automatic event export functionality, for example. But it's worth investing the money to kind of build it around it if it doesn't exist, or paying the extra ridiculous amount of money that, for example, you pay Braze in order to get the data out of there if you're on the basic plan. Of course, we use Snowplow for a lot of this because it has the built-in validation. It has the kind of central schema registry stack. There's also an event design thing here, by the way, which I forgot to mention in the bad data part. Thinking very carefully about what sort of events you define and how you define them is actually quite important. In the first company I worked for, where I did this sort of stuff at Peak Labs, we at some point used to send 70 or 80 different screen view events, just because it was easier for us, we thought, to send a separate event for every separate screen. The downside is you have to define a new type of event every time that the developer adds a new screen to the app. It's much easier to have a central definition of one screen view event with a key value in there that's automatically attached to your screen generation class in your iOS or Android app, for example. So having a little bit of an upfront thought about that, knowing what you're going to use it for, again, is very important. We like Snowplow a lot, so keep it that way. That would be appreciated. Process. We talked about sprints already, standardized events, but also engineering practices. So talk to the engineers in the company if you haven't done so. They literally ask them to sit with you for a few days and and let them tell you all the things you're doing wrong in your coding, because it will pay off at the end. Having proper version control, proper kind of peer review, do not repeat yourself processes, and certainly unit and integration tests in your data science is going to massively de-risk a lot of the pitfalls that we talked about. I also realize unit integration tests are not simple, because, for example, SQL is not necessarily a language that easily lends itself to easy testing. There are ways to set it up where you can, for example, have a QA database running the same data models on top of as you're running on production database, and then having the discipline in your team that no one pushes SQL code to production without having tested it on QA first. I mean, I see someone nodding vehemently here. We found it out to our detriment. It's important. All right, thank you so much for kind of paying attention here and working with me. Any questions? Ask me anything, and happy to oblige. Ooh, Cara.
I have a question. So you mentioned some of the pitfalls, especially around expectation management and bad data. I'd be interested to hear how you've dealt with when you do fall into these pitfalls and you do kind of sometimes damage the trust that people have in the work that you do or in the data that you are giving them. How do you recover from that? What can you do to restore that faith?
Yeah, so there are two answers to that, actually. There's one kind of more political answer, so to speak, a trust-based answer, and there's another kind of more technical answer. So you want to fail fast, you want to fail forward. As in, I can guarantee you that you will fall into these pitfalls, even if you're very well prepared for them. It's about realizing that that's going to happen, almost having a stoic kind of inclination there, making sure that it happens in the first few sprints rather than 10 sprints down the line is very important. Making sure you communicate openly and honestly about that to your project stakeholders. In most cases, they if they have any kind of technical background, they will know that is just what happens to these kind of projects. If they don't have any technical background, you might have to convince them that is what happens in a technical project, but they will be able to live with it. I think the worst thing you can do is try, obviously, to kind of wringer yourself in any sort of bends or corners to make them believe that it didn't happen in the first place. It's the most natural thing in the world. The political answer is, when it comes to building trust, it takes months to build proper trust, certainly in these kind of projects, because they're so important. And it can take just a few seconds to completely lose it, right? The way we deal with that is, obviously, apart from trying not to get in that situation in the first place, is we structure our projects in a kind of how shall I say, multi-owner way, where we have one person at Tasman actually owning the project, doing the day-to-day delivery work, but then we have another person, even if that person is actually not senior in hierarchy in the company to the project owner, whose main job it is to first play red team inside of the company and kind of avoid groupthink and all of those different things, like ask the hard questions in any kind of internal review of a project. But whose job it also is to actually touch base with the client-side project owner, the stakeholder they report to, every month or so for an hour, 2-hour session and say, hey, are you happy? Is everything going all right? Et cetera, et cetera, et cetera. And whenever anything goes wrong in the trust with that project owner and the day-to-day delivery, you have that second person that can go in and say, okay, sorry about this, we're fixing this and this and this and this way, et cetera, et cetera, et cetera. Yeah, there's no right answer, but that's the way we're kind of dealing with it at the moment. Most important is to de-risk early, often fail forward, that sort of stuff. The one time where we really had a problem was when we actually had quite a massive Snowplow implementation problem, which was on our side, not on your side. But we then made it very, very, very clear with like kind of quite a long session where we failed, how we failed, why we failed, and what we're doing to make sure that it doesn't happen again. And that sort of proper kind of debrief is obviously also something that engineers have been doing for years and years and years. But to me, at least in a data science perspective, it's a relatively new concept. But that seems to work as well. Up till now, we'll see. Thank you, Gara. Yeah.
We heard a lot about that Snowplow is adding a lot of data, and your data warehouse is growing quickly. Are there any tools being used to prepare your data first before showing it to your end user?
Yeah.
What can you recommend?
No, that's a really great question, because one of the things that Snowplow allows you to do is not worry too much about event quantity, right? As in if you want to send a heartbeat every 5 seconds that someone is on a web page, you just do it, and then you'll deal with the fallout in your data warehouse later. By adding more nodes, as Stephen mentioned, for example, or paying Snowflake more credits. The way we do it is, and there's actually a little bit of a GDPR angle there as well, if you bear with me for a second. So we write everything to the atomic schema, and anyone who's used Snowplow will be familiar with that kind of event level schema. It's basically the schema in your data warehouse that contains all of the raw event level data. What we expose to the end user is not that. What we expose to the end users, even to some analysts, is heavily modeled data, where, for example, we're following the approach that seems quite common in a lot of startups these days, which is to build, for example, in a heavy user customer-centered app or website, we're building tables with 1 row per user per day since the moment it first signed up, and then put all of the KPIs in there, et cetera, et cetera, et cetera, make it easily cross-tabbable, slice and diceable, and so on and so on. So we can do that. That's very simple SQL. Redshift, Snowflake, BigQuery are optimized for very quick aggregation when it comes to SQL, so you don't need any Spark or Hadoop clusters to do that sort of data modeling. When it comes to actually dealing with the data ourselves, we are heavy users of things like Kibana and so on to understand what is actually in the streams that are being sent. Certainly with Snowplow Enterprise / real-time, having that ability to kind of go into your stream, see exactly what's going on there is very important. When it comes to visualizing the kind of non-typical tables in the data warehouse, we really like Looker's way of coding up the business logic in your data model and having one central place where you can define what is an active user, change it once if you have to change it down the line. When it comes to kind of showing business owners all the different things that are in the data warehouse, there is value sometimes in showing them just the schemas, and then they'll be impressed, so to speak, but it's not really. And the GDPR angle is actually that we're moving to a model where we're actually recommending clients to not expose the atomic level data to their wider analyst community. We say lock it down just so that the sysadmin and the data engineers have access to it. And as analysts, you should only have access to the data that we clean, that we strip of PII, and that we make sure is compliant and is used in the ways that we want it to be used for. As a way. Yeah. There was a question here somewhere as well, I think, or maybe it was. Oh, yeah.
Yeah. You're
Terry.
having a venture-backed startup.
Yeah.
At one moment in time, you have a handover.
Yeah.
So you build your pipeline, the entire infrastructure.
Yeah.
Doesn't sound very easy. So how does that work?
Yeah.
Are there specific pitfalls or best practices you can share in that process?
Yeah, that's a very good question. So what helps, of course, is that we're building all of these things from the start to hand over, right? That's much easier already than kind of having to go from your own internal Tasman instances to move everything to the company's instances that you're handing over to. We also, if you talk about whom we're handing over to, we help companies hire the data team. Because of the fact that we're around and we typically do kind of coaching packages, mentoring packages after handover as well, so that they're not kind of completely dropped off of all support. We typically allow the companies then to also hire slightly more junior people than senior people. We like the fact that Snowplow will have been set up in companies' AWS account from day one. As we say, we actually don't even want to own any of your data. All we want is access to particular parts of your infrastructure, so we can set up the system, so we can make sure it's running, so we can work with Snowplow if there's any problems and so on and so on. But when we do things like setting up Looker, setting up Snowplow, setting up Dataform or DBT for data modeling, everything happens client-side, which means that even if we drop away because of any kind of freak event or whatever, that at the very least the client still owns everything, and that there's nothing to technically hand over at that point. That's a technical handover. Knowledge handover is another thing. We focus on documenting almost everything that we do. So, and one of the things is because we do the same sort of work for a lot of clients, we've got an economy of scale, of course, that helps. We were probably hopefully better after doing something for 6 or 7 times than after doing it only once. And we have more documentation because we need the documentation internally as well.
Yes. And you also have a standard infrastructure or your favorite cloud when you have certain things already pre-scripted?
Pre-scripting comes not necessarily in the form of AMIs or that sort of stuff, like machine instances. So it's not necessarily that we have a whole bunch of Docker images ready to go. We're working on that, as any services company. We're working on kind of automating a lot of the services that we do. However, we are close to that by basically having a whole bunch of data models that we can deploy instantly. So that means that we have templatable SQL. That means that we have things like Python notebooks that we can roll out for any things like driver analysis or churn analysis or conversion driver analysis and so on and so on. Yeah.
Yeah.
Cool. Thank you. Awesome. Thank you, guys.